needs to order at least 20 sandwiches for a meeting. He will order an assortment of 2 types: egg salad for $4 each, tuna salad for $3 each. Otto wants to order at least 10 more tuna sandwiches than egg salad sandwiches, but not more than 15 egg salad sandwiches. How many sandwiches of each type should Otto order to minimize cost? A pretty silly question, but this is the same logic that you would have to do with some type of shipment problem or scheduling problem, and we'll also see that in the homework. But this is kind of silly because it has to do with sandwiches, but it still serves as a problem. Okay, what are we actually asked to do? We're asked to minimize the cost. So this is our goal right here, is to minimize the cost. Okay, well, how much does each thing cost? For an egg sandwich, it's $4. So I'm gonna call it E just so I can keep it straight, but you can use X and Y, that's perfectly fine. $4 for the egg and $3 for the tuna. So I'm just gonna call it T. And my whole goal is to minimize this function. I want the smallest value within the feasible set for that, okay? But I have some boundaries that I have to deal with. So one of the boundaries is that we need to order at least 10 more tuna salad sandwiches than egg. Okay, at least 10 more tuna than egg, but not more than 15 egg sandwiches. So no more than 15 eggs. And we also need at least 20 sandwiches. At least 20 sandwiches. So egg plus tuna has to be at least 20. What else do we know? I would say that these sandwiches have to be 0 or more. The smallest value of an egg sandwich you could have is 0, but it can't be a negative amount. I would say egg and tuna is greater than or equal to 0. Because you can't have a negative amount of a physical thing. That wouldn't make any sense. Okay, is there anything else going on? How much of each type should we order to minimize the cost? So we have 2 variables, and our technique so far with 2 variables is if you graph them, you should be able to find some type of corner point, plug those corner points in your objective function, and that's either the maximum or the minimum. All right, now let's talk about, if we're going to graph it, let's talk about our intersecting points. So for this, if tuna equals 0, egg equals -10. So I need to graph A equals -10 and T equals 10. So those are of interest. I have A equals 15. And then over here, I have A equals 20. Tuna equals 20. Need to graph those. So those are the intersecting points. And so that'll kind of help me of how am I going to graph this? Like what points do I need to graph? So I have 0, 0. I'm in the first quadrant. I am going to have to graph a negative point. It won't be a corner point, but I will have to graph it. Okay, so let's see if we can graph it. The smallest value that the eggs can take is -10, and the largest value that tuna can take is 20. So I think I'm just going to have egg versus tuna here. And I think kind of in my head, I'm going to graph everything by 5s because I have 10s, 15s, and 20s. So it seems like, and the only reason why I'm graphing is just to find the corner points. One, two, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 4. Do that. All right, that should hopefully get me where I need. The only thing I need the graph for is to find where are the corner points. Okay. So we have egg equals -10, and tuna equals +10. So I think we have some line that goes that way. We have 2020. And we have A equals 15 being over here. Okay, so where are we? I think I didn't draw the graph that. I think we're in that top region, but let's look. So does 0, 0 work? This is how I tell where I'm at. So if tuna is 0 and this is 0, 0 is not greater than 10. So we need 0, 0 does not work. So I need to be going the opposite way of 0, 0. So that's telling me I need to be going that way. Okay. Is 0 less than 15? Yes. So this is telling me to go this way. Okay. And is 0, 0 greater than 20? No. So it's saying I need to go this way. Okay. So I think I found my region of interest. Looks like here, here, here. These are my corner points. Okay. The only reason why we graph is to figure out where are the corner points. That's all we need to know is where are they. After that, we can find the rest. So where are they? It looks like they're at 0, 20. That's at tuna equals 20. We're at their intersection, and then we're also at A equals 15. And we don't know what this is. We just know that that's 15. That's a mysterious point. And then here's the intersection. You have to find both of those. Okay. So I have 3 corner points that I'm interested in. Okay. I know one of them. So if I list my corner points, one of them is 0, 20. One of them is 15, but I need to find that other point, and then the other one, I have no idea. But I can solve. Okay, so I have some work to do. The one where egg equals 15, we can find. So we have egg equals 15, and we have t equals 10 plus egg. So it looks like t equals 10 plus 15, which is 25. And now I know that. What's this? I figured out where that is. Where those two lines intersect? I'm not sure. But maybe I could figure it out. What color should I figure it out? How about blue? So I need to know, where do these two lines intersect? Where is this? Where is that occurring? That happens when egg plus tuna equals 20, and we know that tuna equals 10 plus egg. So I think with this, that would be a good case for substitution. And then I could just solve for egg, because I know that tuna is 10 plus egg. So I could solve. So that's egg plus 10 plus egg equals 20. Now it looks like egg would equal 5. If egg equals 5, tuna equals 15. Okay. So I think that's the point. 5, 15. All right. We want to minimize cost. Minimize cost. All right. So this would be 3 times 20, which is 60. This is 4 times 15 plus 3 times 25. That's 75 plus 60. 135. So that'd be $135 if they go that way. Or you have 4 times 5 plus 3 times 15. So that'd be 45 plus 20, $65. So it's either 60, $135, or $65. We want the minimum cost. The minimum was $60, and that came from 0 egg sandwiches and 20 tuna salad sandwiches. The reason I used a graph was to find the corner points. That was the only purpose to find, or to use the graph at all, was just where are my corner points. Everything else was simply to solve where that was. Now, this is unbounded. This region has no boundary. Let's see if I can show that. And that's just going to keep going. That just keeps going up, 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 up. Okay, so you can continually buy sandwiches. You could buy sandwiches forever, but that would not minimize your cost, but it would meet the other boundaries, okay? So I guess you could buy an infinite amount of tuna sandwiches, but it wouldn't minimize cost. We found the one point which satisfies the boundaries and minimizes the cost. So the fundamental theorem of linear programming says that the maximum or minimum will lie on one of those corner points, but it doesn't really promise us which one.